Today's lesson is super important because we're going to learn where trigonometry, sine, cosine, and tangent come from. What are those words? Where are they coming from? Trigonometry is the study of right triangles. So we're going to connect what we've been doing with right triangles and sine, cosine, and tangent. So we've been talking about reference angles, opposite side, hypotenuse, and adjacent. Remember that hypotenuse is always the longest side across from the 90. And this reference angle affects how big the opposite side is, right? As I make that angle bigger, that side gets bigger. So those are some big ideas. And this works because all right triangles with the same angles are similar. So the opposite divided by the hypotenuse here, A divided by C for this 20-degree reference angle is going to be equal to this triangle, B divided by B. It's always going to be the same when the reference angle is 20 degrees in a right triangle. Always going to be the same ratio. So let's look at an example of what we mean by this. So if I look at the green triangle, the opposite side here is 1. The hypotenuse is, across from the 90, is 2. Opposite divided by hypotenuse is 1/2 or 0.5. All right, let's look at a bigger triangle, right? I'm going to make this triangle twice as big. So 1 times 2 is 2. 2 times 2 is 4. Now this triangle is twice as big. The opposite side is 2. The hypotenuse is 4. So I'm going to do 2, 4. And then I'm going to do opposite divided by hypotenuse. I still get 0.5. This is what I mean by all the ratios are the same if that reference angle is the same. So let's make this triangle 4 times as big. Go from green to purple, 4 times as big. Now the opposite side is 4 and the hypotenuse is 8. All right, opposite side is 4, hypotenuse is 8. 4 divided by 8, it is still 0.5. So when I have a 30-degree angle, the opposite divided by the hypotenuse is always 0.5. And if you notice when we did the reference tables or ratio tables the other day, if I look at a 30 degrees, I did the opposite divided by the hypotenuse, and it is 0.5. So this table just has all the possible angles and ratios we could need. Now you're probably saying, Mr. S, what if there was like a 21-degree angle? I don't see it in the table. So mathematicians have a full table of everything, but who wants to memorize that or use a big table? There's an easier way to do it. If I just put in sine of 30, I'm going to get 0.5. All sine means, they just name the opposite divided by the hypotenuse is called sine. The adjacent divided by the hypotenuse we are going to call cosine. And the opposite divided by adjacent is called tangent. So you've probably seen these 3 buttons on your calculator: sine, cosine, and tangent. That's all they mean. Sine means opposite divided by hypotenuse. Cosine means adjacent divided by hypotenuse. Tangent means opposite divided by adjacent. And then it will tell you the table or the decimal that you would get. So for 30 degrees, opposite divided by hypotenuse is always 0.5. We see that. So sine of 30 is 0.5. It's just naming that table. That's all it is. It seems confusing, but that's where it's coming from. So here's the key ideas that we just talked about. Make sure you see it in your notes. And then notice that if you want to find cosine of 30, if you want to know what's that decimal going to be, it's going to be 0.86. So 0.86. If I did sine of 30, I would get 0.5. We just did that one. And then if I did tangent of 30, I would get 0.577. So we can know all these ratios just using our calculator. It makes life way easier. So that's where it's coming from. So big ideas that you want to write down or see in your notes. Sine is the opposite divided by the hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent's opposite divided by adjacent. An acronym to help you remember this is SOHCAHTOA. SOHCAHTOA. And all SO means is sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Sine, cosine, tangent is opposite divided by adjacent. So if you memorize SOHCAHTOA, it'll just help you keep track of sine, cosine, and tangent. Then we used it to find a missing angle.